History of optics. Optics began without the development of lenses by the ancient Egypt and Mesopotamians. The earliest known lenses, made from polished crystal, often quartz, date from early as 2000 BC from Crete Archaeological Museum of Haralson, Greece. Lenses from Rhodes date around 700 BC. The word optics comes from the ancient Greek word optike meaning appearance, look. Plato first articulated the emission theory. Some 100 years later, Euclid 4th-3rd century BC, wrote a treatise entitled Optics where he linked vision to geometry, creating geometrical optics. Ptolemy, in his treatise Optics, held an extra-mission-intromission theory of vision. Al-Hazan. Ibn al-Haytham, the father of optics, reproduction of a page of Ibn_Saul's manuscript showing his knowledge of the law of refraction and reflection Muslim world. One of the earliest of these was Al-Kendi, BC. 801 to 873, he wrote on the merits of Aristotelian and Euclidean ideas of optics, favoring the emission theory since it could better quantify optical phenomena. In 984, the Persian mathematician Ibn Saul wrote the treatise on burning mirrors and lenses, correctly describing a law of refraction equivalent to Snell's law. He used this law to compute optimum shapes for lenses and to curved mirrors. In the early 11th century, Al-Hazan Ibn al-Haytham wrote the Book of Optics, Kitab al-Menaazir. In the 13th century in medieval Europe, English Bishop Robert Grosseteste wrote on a wide range of scientific topics, and discussed light from 4 different perspectives. First treatise about optics by Johannes Kepler, Advitellio. Nem. Para lipo. Nina ki bus astronomiae pars optica. Tra. D. Tur. 1604. In the early 17th century, Johannes Kepler expanded on geometric optics in his writings, covering lenses, reflection cover of the first edition of Newton's Three Optics, 1704. Optical theory progressed in the mid-17th century with treatises written by philosopher René Descartes, in the late 1660 and early 1670. Isaac Newton expanded Descartes' ideas into a corpuscle theory of light, by Robert Hooke in 1664. In 1704, Newton published Optics. Newtonian optics was generally accepted until the early 19th century when Thomas Young and Augustin Jean Fresnel conducted experiments on the interference of light that firmly established light's wave nature. Young's famous double-slit experiment showed that light followed the superposition principle, which is a wave-like property not predicted by Newton's corpuscle theory. This work led to a theory of diffraction for light and opened an entire area of study in physical optics. Wave optics was successfully unified with electromagnetic theory by James Clerk Maxwell in the 1860s. In 1899 when Max Planck correctly modeled blackbody radiation. In 1905, Albert Einstein published the theory of the photoelectric effect that. In 1913, Niels Bohr showed that atoms could only emit discrete amounts of energy. Quantum optics gained practical importance with the inventions of the maser in 1953 and of the laser in 1960. Following the work of Paul Dirac in quantum field theory, George Sudarshan, Roy J. Glauber, and Leonard Mandel applied quantum theory to the electromagnetic field in the 1950s in 1960 to gain a more detailed understanding of photo detection and the statistics of light.